Okay, so this is part 2 of undetermined coefficients. We learned some pretty basic guesses last time to guess what YP is and then plug it into the differential equations and then equate coefficients to figure it out. So do you think guessing always works so well? So my answer is probably not, and that's why we have this part 2. So here's an example. So here's a non-homogeneous, and this is our g of x. So I just want to look at our first guess. I call it our first guess because it's or kind of like your raw guess for a YP. We look at g of x, and we guess something similar. So I'm going to guess a e to the x. So then you want to solve for yc. So this is our homogeneous solution. So we set the left side equal to 0, the corresponding homogeneous dE, and solve for it. We can use constant coefficients, since that's what we have. So we'll plug that into our dE. Y double prime. Factor that out. So this is our second case of constant coefficients. My fundamental set, since r is equal to 1, and this is my solution, it's e to the x. And for our second one, we did an independent solution of that, so we multiply it by x. So now we have our 2 independent solutions. This is my fundamental set. And so my YC, we can wait to write YC out later, but I'm going to write it out now. And then I want us to go back and look at our raw guess. So if our final solution is supposed to be YC plus YP, so the particular solution to the non-homogeneous added to the homogeneous solution. If I look at my guess, my first guess of YP, which was right here, a e to the x, and we look, if I add those together, what's going to happen to that YP? This term here will get absorbed into this term. That a and that c will be added together, and then our YP won't be there. So that's why I call this our raw guess. The first one, when you just look at it, that's our raw guess. And then we solve for the homogeneous right here. And then we have to find YP, which is independent of everything in my fundamental set for YC. So we need to just take this and make it independent of those two. So we can next try this. This definitely, multiplying by x makes it independent of the first one, but now we still are not independent of the second one. So what do you think we'll have to do? We'll have to multiply it by another x. So again, that's not going to work. This is not going to work. It's not independent of this one. This is not going to work. It's not independent of that one. So my final one, which should work, is x squared. Multiply it by another x. And let's not forget, we need to have an a in front because we need to solve for that a. We need to find a particular solution. Ax squared e to the x. So let's try that. So we're going to plug this in to our non-homogeneous dE and equate coefficients to find what a is. We need to do the product rule. Product rule here, twice. Or we could factor this e to the x out and then just do the product rule once. either way. So before we plug that into our d, let's clean it up. We can factor that out. My yp double prime. Let's write out our dE. This is our dE we're trying to solve. So we plug our guess into there and equate coefficients. Let's clean up the left side so we can equate the coefficients. If you notice, though, we have an e to the x, an e to the x, an e to the x, and e to the x. I could divide out by e to the x on both sides. It gets distributed. And they're all gone. Let's add all our like terms. Oh, those actually go away. Those go away too. So A is 5/2. So my general solution is still y equals yc plus yp. Our yp, by the way, because A is 5/2, our guess was that this was our yp, so it's 5/2. A is 5/2 x squared e to the x. So y equals c1 e to the x plus c2 x e to the x. This was my yc plus 5/2. This is my yp. And that's my final solution. So we're going to solve this initial value problem. Third derivative. So this is a third order. So therefore we have 3 initial conditions to be able to solve it. We're going to start off again. I'm going to do my raw guess. Since this is a plus, we use the superposition principle. Yp equals, this is my raw guess for my particular solution. So first we do have to find the general solution, of course, and then we plug in our initial conditions to find the, we should have C1, C2, C3, since this is a third order. And so my raw guess would be, whoops, instead of 2, it would be A. And then the solution for sine of x, if you remember from last time, if you just use, can't use A sine of x, we have to use B sine of x. If we're going to have sine of x, any derivative of sine of x needs to be included. So we do know we also have to include C cosine of x. And this order wouldn't have mattered. So that's going to be our raw guess. But now we have to find yc to make sure that each of those are independent of our homogeneous solution, so it doesn't get absorbed. So we guess our yc, no, I'm sorry. So we're going to find yc, which is the solution to the corresponding homogeneous, which would be, this would be our homogeneous equation that we need to find yc from. And so we are going to guess e to the rx. These are constant coefficients. So we plug in for just those 2 terms. And this is our first derivative here. Factor that out. So we need to solve for this. It has an r in common. And we can see if I set that equal to 0 and solve, it's going to be plus or minus I. So it's 3 solutions. It's third order where there should be 3 solutions. So plus or minus I. So it is 0 plus or minus I. So my alpha is 0. So my e to the 0 x is just 1. So basically, this e to the 0, it's e to the 0 x. And then the e to the 0 x that's part of my imaginary ones is 1. And so beta is 1, because that's the coefficient in front of there. And so it's basically cosine of beta x, which is 1x, and sine of x. And this e to the 0x, so basically it's 1 cosine of x, sine of x. So this is my fundamental set, which is basically my 3 independent solutions for my homogeneous. And so now we take our raw guess. Remember our yp, our first guess, is yp equals a plus b. And we can see every single one of these. This is not independent, this is not independent, and this is not independent. So what we want to do is we want to multiply x. I think x will take us out of that one and these two. So we can just put an x, bx. We can multiply an x there and an x there. And that should do the trick. So our yp, our particular solution, will be ax plus bx sine of x plus cx cosine of x. We've got to plug it in. So we have to take the product rule both times. And this is going to be a little bit messy. And then we plug it in, equate coefficients. And I'm just going to skip all the steps here and tell you what the answer is. You can do the work on your own and check this answer. But solving this and finding the second derivative and plugging it into our dE here. Again, we have to actually find all the way to the third derivative. So it's a lot of work. But I want to skip to the chase. And we will get a equals 2. B equals minus 1/2, C equals 0, and so therefore yp, plugging a, b, and c into there, 2x minus, so my y equals yc plus yp. We can look at our fundamental set. My yc comes from there, so y equals, oops, I guess I should circle this one. This is better. This is my fundamental set. And so my yc is c1 times 1 plus c2 times cosine of x plus c3 times sine of x plus my yp. And we're not quite done because this was again, this is my yc, this is my yp, plus my yp. This was an initial value problem. Let's pull those initial values down and plug them in to our general solution. So we plug this one in. I get 0 equals c1. Cosine of 0 is 1, so c2. That will zero that out. That'll zero that out. That'll zero that out. Okay, I plug in our second one. Plug in 0, we get 1 equals, well, I guess we do need our first derivative and second derivative. So we would have to take the y prime here, and then we'd also have to find the second derivative, and skipping the chase, not doing the work, we are going to get 1 equals c3 plus 2, and for our second derivative, we get minus 1, we plug minus 1 in, and we get c2 minus 1 equals minus 1. So we have these three equations. Looks like here we can solve for c3 pretty easily. Our c2 here. Oops, I guess I didn't need this. I already wrote that on the left side. c2 is 0. And this one, c1 plus c2, 0 equals c1 plus 0, c1 equals 0. So going back in and plugging these values in for c1, c2, c3, that'll zero that out, that'll zero that out. We get minus. So I just want to remind you, I didn't do the work of writing out the first derivative and second derivative, but this does come from writing out the first derivative, second derivative, and plugging in these values. Okay? Feel free to check the work yourself. Our next example. So your first guess of YP is A cosine of 2x plus B sine of 2x. Remember, it has to include the derivative. Any derivative of your g of x needs to be in there. So that's why we have to include sine of x. We're going to find YC next to make sure those values don't get absorbed into our homogeneous solution. So plugging it in. So my alpha is 0, my beta is 2. So my fundamental set is cosine of 2x, sine of 2x. This is for my homogeneous solution, my YC. So my YC equals A cosine of 2x plus B sine of 2x. And you can see both of these would get absorbed into that, and my YP would be 0 if we found A and B, if we were able to. You'd probably get a contradiction anyways if you tried to solve for that, for A and B. So my second guess, my final guess, is we need to multiply those by something to make it independent of our homogeneous solution. So that's just going to be x. So my YP is going to be AX cosine of 2x plus BX sine of 2x. And of course, if I asked you to solve this, then you would take the first derivative and second derivative of this, plug it into the non-homogeneous equation, this, and then equate coefficients to find A and B, and then write your final solution. So let's first start off with finding our first guess of YP. Just looking here without solving our homogeneous. So our first guess has an A there. It's a constant, so we will use YP equals A. Now our second one, we have to use the superposition because it's plus or minus that. So it's plus, but be careful. We have to include every derivative of x to the square. So we'll need a quadratic there because the first derivative and second derivative, we need to go all the way to the fourth to a constant. So we will have to use bx squared, I need more room, plus cx plus d, that's my quadratic in front, times e to the minus x. So this is the superposition. There's two terms of our g of x, and so we have two of them, two guesses, I should say. And this is the form, the general form of this, because we have to include every derivative of x squared, so we have to use the quadratic to make, when we're taking the first derivative and second derivative, they all need to be there in order to equate coefficients so it doesn't fall apart. And we're not done, because now we need to make sure it doesn't get absorbed into our YC, so we need to find YC. YC is the homogeneous, corresponding homogeneous, which I take my left, set it equal to 0. This is going to be y equals e to the rx. Okay, so we need to plug this in, factor that out. And that'll never equal to 0, so we have r equals -1 and 0 with the multiplicity of 3. So we need to make sure we definitely do need to have 4 independent solutions because it's fourth order. So my fundamental set is e to the minus x, and then e to the 0 is 0x is 1. So 1, and then we multiply that one by x, and then we multiply it by another x, and we have our fundamental set with 4 independent solutions in there. So now let's look at our first guess right here. And look at this term. This times this, that is that term. That will get absorbed in there. Our constant, by the way, will get absorbed. We can't have that in our YP. So let's write this out. We can treat these separately. We don't have to multiply the whole thing by 1 power of x, but you have to treat it as 2 separate identities. I mean, we have to treat it as 2 separate using the superposition. So YP, just copying, is A. Okay, so looking at comparing our first guess with so comparing our first particular solution with our fundamental set, we need to look at this one first. And this one we need to multiply. It's basically could get absorbed here, or if I multiply an x, it'll get absorbed here. If I multiply by x squared, it'll get absorbed here. So I will have to multiply this one by x to the third to make it independent of those two, so it does not get absorbed into my homogeneous solution. Over here, just this one right here, is the only one that's going to get absorbed there. So if I multiply by x, that's going to work, because now it'll be dx e to the minus x. That makes it independent of this, and of course all the others will be independent, but you have to multiply all of it by x. Can't just multiply that one, because then that one would get absorbed into c of x, and so on and so on. So my YP, my final YP that will work, is this. Okay, so you can treat them separately. So here's a table. On the left is these are our g of x's. On the right, this is our first guess. This is our first guess of our YP. Okay, and then the process would be, then you would find your homogeneous solution and then compare it and make it independent of your homogeneous solution. So you have 2 steps to find YP. So as I've told you already, if it's just a constant, use A. If it's a linear, you have to use ax plus b. It could just be x squared, and you would use ax squared plus bx plus c. So, because notice how it's 3x squared minus 2, there's no x term, but you have to include the x term here because you have to include all the derivatives. A third degree will have ax to the third and all of the lower powers, all the way to the constant. Sine of 4x, again, you have to include the sine and the cosine. If it's cosine, you have to include the sine and the cosine, because when you take the derivative, that's got to be there. Same with these. You take the derivative's there, and then this derivative needs to be there, and so forth. This one's the easiest. You just put a constant in front. And then these are what combinations look like. We've already done one with a quadratic in front. Here's one with a linear. So you need an ax plus b in the front of e to the 5x. Combining. Again, I think we had a similar one like this. You have x squared. You have to put ax squared plus bx plus c, just like you have to up here. That's what's in front of e to the x. And when you have a combination of sine of x, you got to have sine and cosine with this in front, with a different a and b in front. And so same with this one, you have to have your ax squared plus bx. You got to have the sine of x. Then you got to have ax. You can't use ax and b and c. You got to use new variables times. You have to have your sine and your cosine. And I don't think I'd give you this one with 3 of them, but you've got your linear and this. And then you have to have a different linear, different coefficients in this with the sine and cosine. Okay? Hopefully that helps. Find your homogeneous after that and multiply. If you're using, there's no superposition over here, but if we had this plus sine of x, well then that would be plus d sine of x plus e cosine of x. Just to show you, I can utilize a superposition for your guess, but you do have to include new letters. And you would treat this and this separately as far as multiplying by powers of x to make it independent of your homogeneous. Okay? Hope that helps.